Problem description. Within a quarter circle, a rectangle is inscribed. The objective is to determine the area of this rectangle, based on the numerical data shown in the figure. The fundamental breakthrough in this problem is recognizing that the line segment connecting the center of the circle to the opposite vertex resting on the arc is by definition the radius r of the circle. This radius simultaneously acts as the diagonal of the rectangle. Algebraic expression of the sides. Using the radius r and the provided numerical data, the dimensions of the rectangle can be expressed as follows. Vertical side r minus 2. Horizontal side r minus 9. Formation of the right-angled triangle. Consequently, the diagonal splits the rectangle, forming right-angled triangles. We can isolate one of these triangles where every single side is defined strictly as a function of the radius r. This reduction allows the entire geometric system to be solved using a single variable via the Pythagorean theorem. Solving the equation. We begin by expanding the squared binomials on the left side of the equation. We simplify the algebraic expression, yielding the quadratic equation, r squared minus 22r plus 85 equals 0. To solve for r, we can factor this quadratic expression. Finally, we find that r can be 17 or 5 centimeters. Returning to the original figure, we observe that if r equals 5, the base of the rectangle becomes 5 minus 9, which equals negative 4, a geometric impossibility. Conversely, if r equals 17, the two dimensions of the rectangle are 17 minus 2, which equals 15 centimeters, and 17 minus 9, which equals 8 centimeters. Finally, we find that the required area is 15 times 8, resulting in 120 square centimeters.